Okay, guys, so we're going to talk about gravity. Now, the theory of gravity has a few flaws, but let's look at it for a minute. There's Newtonian physics. Now, Newton was a very smart guy. He figured out that we have gravity on Earth. But then he turned and applied that theory to space and to the bodies in space, and I'd like to talk for a second about why that theoretically is bullshit. Firstly, when you look at gravity, how it affects things. Let's say we say a stone has density, therefore it has gravity. The Earth is a much bigger stone, has a lot more gravity. The stone has so little you don't feel it. The planet has a lot, you feel it. But the principles are the same, so bear with me. Let's say we take that into space. You know that it has no weight in space, right? It's in a vacuum, and it's weightless. It just floats around. Therefore, stating that our planet's weight has anything to do with how objects travel in space is foolish at best. Einstein believes that space-time are linked, and that when a planet is sitting there, it dimples the fabric of space-time because it's a sheet of paper and the planet's sitting on it. Only that doesn't make any sense. Watch my video on space-time to see why. In this one, we're going to stick to gravity and the principles of gravity and what that says. The problem is, as soon as you put that object into space, gravity stops being an issue. Gravity doesn't actually work in between planets. How can it when they're both weightless in space? You might think. But gravity, the theory of gravity says that it will. That these will happen to these two rocks. They'll be drawn together in space. Well, we have space debris floating around in space, lots of it. How come all the smaller pieces aren't sticking to the larger pieces? How come they're not orbiting them? They just get drawn into Earth until it crushes them, until they come into the atmosphere and crash into something. And then by definition, they have crushed themselves against the Earth, but the force of gravity is responsible. Well, that's true. That's gravity. But you can go out in a ship or in a space station and thrust out far enough that you're no longer in that magnetic field or that gravitational field. Now, they say that is not electromagnetism. That's gravity. Okay, well, I agree with them because electromagnetism really at this point has nothing to do with it. And that is the problem. Traditionally, they say that electromagnetism has nothing to do with how bodies move in space, and it is based on physics that are derived from a rock-solid Earth, and we're standing on it. The problem is when you go out to a space, those go out the window, and they no longer apply. And we know this in a variety of ways. For one, during the Apollo program, they exited Earth's atmosphere, traveled to the moon, slingshotted around it, and came back. When they left Earth, they did a burn, accelerating them away from Earth to get up to the speed they needed to be for the trip. They get to that speed, they cut the throttle. From that moment, as far as I know, they didn't have to apply more throttle, and they weren't losing speed. Had Earth been still pulling gravity on them, they would have slowed down. And they didn't. Instead, they got to the moon, and as soon as they got into the gravitational field of the moon, which is pretty close to the moon, certainly not reaching to Earth, Earth's gravity field certainly not reaching to the moon, it started to do an around the world type of trip, going 180 degrees from pole to pole and slinging out the other side. What it did there was slingshot faster away from the moon than it approached. It increased speed during that, which means if gravity was the only thing keeping our planets rotating, not only should they have spun away from each other a long time ago with increasing speed, they should have increased speed until they escaped. Now, had they continued around, they would have fallen into orbit. But they didn't take a trajectory that would fall around into orbit. Do you know how hard it is to get an object into orbit by gravity? It's actually not that easy. It's far easier to not have it work out properly and for you to just fly off or skip off the atmosphere than it is for you to actually be in a proper orbit. It's easier to crash into the planet than it is to be in a proper orbit. And once you're there, gravity is in effect and you have to hold yourself there. But if you park your ship between the Earth and the moon, you'll find that there is no pull. And if we put two big rocks in space, really big, they don't gravitate towards each other because there is no gravity in space. There's none. You're weightless. So how does your specific density matter anymore? By theoretical definition, space should obliterate gravity. However, in the experiment that I've just posted, there's a description of how this could theoretically work based on the laws of electromagnetism, repulsion, retraction, and suspension of those forces. And if you believe they cannot be balanced and suspended, this experiment actually demonstrates that physically using bipolar magnets. Nothing else. And this demonstrates partly how an orbit could happen because I show it. At one point I let go of a magnet set, and it, instead of being attracted to the set that it is attracted to, it has a positive and negative. It flips out of my hand and goes around it in a perfect arc. The reason it does that is because of electromagnetism, not gravity. While gravity doesn't do an excellent job of explaining the motions of the universe, electromagnetism actually does. Gravity does a wonderful job of explaining weight on Earth. But in my opinion, it just doesn't bear any weight in space. Keith out.